Hello guys, we're going to perform some geotechnical analysis using Hyrcan, that is free software, free license software that is useful to solve slope stability problems. I'm going to use this software because it's available for us for free, and just also this is very useful guys to introduce you to the world of numerical modeling, numerical advanced modeling. So, why? Because we are going to be using line commands in order to get our model. So, this is very useful if you want to design, even in structure, hydraulic, and of course, in geotechnical engineering. This is very useful for you guys if you want to be performing in the future very advanced models. So I'm going to start just by indicating that you can get this Hyrcan software just in this web page that I'm going to write down in the comments. You can access through this web page and just to download, and then you are going to get this warning, and just ignore this warning and continue with the download. And also I recommend you guys to get this high syntax for highlighting for Notepad. Notepad is just to script, just to coding. So for instance, this is Notepad and you can save and to get the text highlighted that I am showing you guys. This is very useful just to go through the model and to identify possible errors when I am coding, but also you can get the normal text editor and just to run the model. So I'm going to be solving the problem just in the traditional way first. And for do that, I'm going just to be solving this problem that I am. This is the same problem I solved by using Plaxis equilibrium limit, and now I am just to use Hyrcan. So I'm going to start just with a new model and just defining the external boundary. Okay, so as you can notice, it's very complicated for me to define the coordinates of the model. So even though it's very useful, it's very easy just to go to picking, but it's not so easy to define the coordinates in the software. So to solve this, I need to go by commands, using command. As you can notice, you have a line window. In this window, you already have the commands you are applying. So I'm going to start to script my commands, and I'm going to initialize in the new model. And then in order to do that is just to write the command new model. And the second step is to define the boundary of my problem. So the boundary of my problem in this case is just all these coordinates that are in the boundary of my problem. So I have to start from 0 to 0, and then I have to finish to 0 to 0, because this is very similar when you are just drawing boundaries in AutoCAD or something like that. You need to start and to finish in the same point. So I am just going from point to point until finish all my coordinates. So you can notice 0 and 0, 0 and 0, then 0 and 24, 0 and 24, 24 and 24, 30 and 28, etc. Okay, so I have just adding, I'm going just to show you guys. So I'm going to file and then load script, and then it's just Hyrcan example, And just by magic, now I have my external boundary. So it's not needed to go to AutoCAD. So it's easier for you guys to go to the command lines. So the second step is just to define the boundaries from the different layers of soil that are involved in this problem. So I have the first layer that is in these lines and two, and so I already have this one, just, and then the step number three is just to define the soil layers. In order to do this, I'm going just to go for this command that is mat boundary, and then I am just how many layers I have. So in this example, I have three different layers divided by two boundaries material. So the first boundary is in this coordinates. So I'm going to start in the point 30 and 28, and I'm going to finish in the point 60 and 28. So I'm going to save my model. I'm going just to show you the result in order you can get. Now you already have this um, soil layer. And I'm going to define a second soil layer by using the same command, but of course, I'm going to modify the coordinates. So 24 and 24, from point 24 to 24 to point 60 and 24. 60 and 24. And now, so I'm going just to add this. And you can notice you already have the three different layers that I have in my model. So I have three different layers here, and also I have three different layers in the model. Now, what I need is just to define the materials, the properties of my layers. So in order to do this, I'm going to add a new command that is useful to define the material properties. So, and I'm going to use this define material. I'm going just to copy all these, okay, guys? So I'm going to define the material. As you can notice, I am just adding an ID. This is material number one. The name of my material is arcilla, or I can just modify to clay. And this is the unit weight. So for this case, the unit weight is just 15. So the unit weight is 15. The cohesion of my model is 5 kilopascal, not 25, but 5 kilopascal. And the friction angle is 30 degrees. So I'm going to have this value, I'm going to save, but also I have a second material, okay? So the second material is material ID number two, and the name I'm going to use clay or sandy clay, just to write some names, different names. And the unit weight is 18, 18, and the cohesion is equal to 27 kilopascal. So I have 27 kilopascal, and the friction is equal to 28. So I'm going to use 28 degrees, okay? And just, I'm going to load my script, and I want to show you that there is not new changes in my drawing, but in my line command, I already have defined two parameters. I can open these defined materials and I can notice that here I already have the clay and the sandy clay material that I was defining before. So I'm going to continue adding a new uh, properties, a new material. So this is material number 3, okay? And material number 3 name is, I don't know, silty sand, okay? And the unit weight is 20 kilonewtons per square meter, per cubic meter. So now I have 20. The cohesion is equal to 19 kilopascal and the frictional angle is equal to 20 degrees. So I already have defined all my properties. Then what I need is just to assign these properties to my model. So it's just to assign the material properties to my model, So I'm going to use a new command that is called just to assign. I need to go to my model and assign the properties to different layers. For instance, I'm going to assign material 1 at the point is just I have to select a point inside the region of my material, of my soil layer. For instance, here I have, I can select just the point 14, maybe 14, and then just to select 40 and 30 instead of 32, just 40. Okay, no, 40 no, but 30, 30, okay? So I have the soil material. This is similar just to click on this point. I'm going to show you guys. So if I load the script, oh no. If I load the script, oh no. Okay. So I already have material number 1 that is clay. And then I'm going to do the same, but the second material, okay? Material number 2, and then is 40, and then I'm going just to click on 45. As you can notice, 44 between 44 and between 24 and 28, I can just choose 25. So I'm going to choose 25, and then I have a third material that is material number 3, and then I'm going to click on the point 40 and 10, okay? And now I'm going to save, and I'm going to load my script. So, and now notice you already have the 3 different materials, and you have the properties, you have assigned the properties to your model, and now you can apply the loading condition. So you can add the distributed load that in this example is 25 kilopascal. I'm going just to show you how can you learn new commands. So as you can see, you can use this software as you already know, but I encourage you guys to use the command lines. So I'm going to apply this command here. Apply 6 is to apply the distributed load at the top of my slot. So I'm going to use this. You can notice that you have apply load. You are applying a constant load. The load is number one. The magnitude is 25. The orientation is normal to the surface, and you are starting from point 36 to 32. That is, this coordinate is this point, and you are ending your loading in 60 and 32. So this is very straightforward. And then it's just to save. And then I'm going just to show you guys how easy is just to get the model. And now you already have the model, and you in this point you can get the results from the static condition. So I'm going just to click on compute, okay, and I'm going to get the factor of safety, and also I can get these forces. So and you can compute and show slices. This is very useful for you guys just to learn how to you can learn, you can discover new commands. Okay? Because the commands are very useful because just compute and just show slices. And then and- okay guys, so I'm going just adding this condition. Okay. Okay, so it's doing everything automatically. And you cannot, you already have the results. So you don't need to worry about just to go into this menu. No, it's straightforward. Also, you can apply this service with factor below to apply, and there are no, and then just okay. Mhm. Okay, guys. So I'm going just to continue by analyzing a different condition. So I'm going to do the same analysis. So let me just to realize. So I'm going to do this the seismic condition analysis. So as you can notice, you have two different coefficients, the horizontal coefficient and the vertical one. So in order to be adding this condition, I'm going to modify my script. So this is the reason why using command lines is very useful, because once you get your first model, you can continue adding other conditions. So for instance, I'm going to add a new condition. This condition I'm going to call seismic loading. Seismic loading. So in order to add, I'm going to apply a new comment that is apply load. Okay. So I'm going to use this. As you can notice, you also are using the same command that you apply for adding the uniform constant load at the top of the slope. But in this case, you are modifying to seismic loading condition. and the horizontal coefficient is equal to um, 0.08, 0.08, and the vertical one is 0.03. Okay, so I'm going to apply this condition and I'm going to solve my problem again. Okay, so I'm going to solve the problem for the um, seismic condition. Seismic condition. Okay, so I'm going to save and I'm going just to load my script. And now, yes, you can notice that in this case, we have a lower factor of safety. The factor of safety was something very near to 2, and now because of the seismic loading, I am just getting 1.7 factor of safety. So you can notice the effect of the seismic loading. Okay, and now finally, I'm going to go to the model, to go back to the model, and I'm going to add this surface water, okay? I'm going just to pick very near, and just say this is my water table, okay? So I'm going to modify seismic loading, and now I'm going to add the water table level. So to do this, I'm going to use a new command that is add water table. This command, okay, I am going to add, and I'm going to start by 0 and 24. This is point by point, 0 and 24. And the second point, I'm going just to say 36 in X and 30 in Y. And finally, 60 and 32. Okay, so I already have my water table. I'm going just to, okay, just to compute. And of course, I'm going to get a lower factor of safety. Loading, I'm going to load my script. Okay. Oh, no. Here is something going wrong. Okay, so why is okay, because it's missing one point. 0, 24, 24, 24 is missing 24 and 24 point. And also, I want you just to learn something from my mistake. It's 1.5, and now I'm going to load. And now I am having just a lower factor of safety. Okay, 1.3. So this is my condition. This is my solution. Okay. And for me, this slope is very, um, is behaving accordingly to the design's guidelines and design code. So you can go for it in the reality and you can just to do the proposal for construction. So this slope is working perfectly despite the seismic loading, despite the water table. Our factor of safety is 1.3, that is acceptable for, and is almost by sure that if the soil characterization was accordingly done, the slope is going to behave to perform very good. Okay, so this is all, guys. So now You have all the elements to finish your assignment. Bye bye.